Welcome back to Function Notes Video 2. We're going to use the same table that we just made in our notes to add on to what this tutor tells us in this video.
Functions. A hummingbird beats its wings about 52 beats per second. The total number of times the hummingbird beats its wings, the output, depends on the number of seconds, the input. This relationship can be expressed as a function. A function assigns exactly one output value to one input value. Let's organize the input-output values in a function table. The first column is the input and the last column is the output. The function rule is an expression that describes the relationship between the input and the output. Remember, the hummingbird beats its wings 52 beats per second. If s represents the number of seconds, 52 times the value of s, or 52s, is the function rule. Now let's fill in the function table for input values of 1, 2, and 3 seconds. We'll put a 1 in the first column to represent the input of 1 second. In the second column, replace s with 1. So our expression is 52 times 1. And for the last column, wing beats, the output is 52, because 52 times 1 equals 52. Continue to complete the table for 2 seconds and 3 seconds. What expression would you write for 6 seconds? That's right, 52 times 6. So a hummingbird could beat its wings 312 times in 6 seconds. This is only one example of a function that represents a real-world situation. Can you think of others?
Next, we are going to listen to another tutor show us how to use another function table. Please write the function table that she uses in your math notebook and fill in the data that she puts in as she goes along. Go ahead and write this input-output table underneath our table about the wing beats. You do not need to write the words up above here. Just draw this table for me and fill it in as Mrs. Workman takes you through how to find the output from a function table.
Hello, this is Mrs. Workman. The output value is 3 less than the input value. Complete a function table for the input values of 8, 9, and 10. Let's look at our function table. In the first column, we're given all of the inputs, which are n values. In the middle column, we are given the expression n minus 3, input minus 3. And we're told in the problem that the output value is 3 less than the input value. That's right here. And in the last column, we want to find those output values. And we're going to do this 3 times. So now I'm going to take my 8, which is my first input. That's the n value. And it goes into this expression. 8 minus 3 is 5. So for this function, when the input is 8, the output is 5. In the next case, the input value is 9. So we're going to go back over here to the expression and replace n with 9. 9 minus 3 is 6. So when the input is 9, the output is 6. Finally, the input value is 10. 10 is n. So we're going to replace n with 10. 10 minus 3 is 7. We know that when the input is 10, the output is 7. We have now completed this function tables for the given input values.
Now we are going to practice a couple more function tables, trying out different function rules. This is very similar in our earlier units when we had certain values for x that we plugged into the solution to discover. We are just now calling them functions instead of equations, and we are organizing them into a table. So please draw this table in your notebooks with the input being x and the values 0, 2, and 5. The rule would be 3x, and then we will figure out the output by substituting in the input numbers for x. Don't forget that this input is also known as the independent variable, the IV. We can choose any number we want to input into this column if we continue to make rows below, but the output is going to be dependent on what we plug into the input. Now that you have your table drawn, let's go ahead and solve this. For 3x, we know that means 3 times 0. So the only output we can get is 0. If we knew the output but not the input, there would only be one value that the input could be. Therefore, again, this last column is dependent on the input. Do the second and third row on your own and see if you get the same answers as I do. You should have done 3 times 2, which is equal to 6, and 5 times 3, or 3 times 5, since we know that multiplication is commutative. Great job. 5 times 3 is 15. Let's do one more chart together. Go ahead and draw this one on in your math notebooks. Again, we're going to have an input column, which is also going to be known as our x value. It's going to be the independent variable. We're going to put a rule here. And this time, let's do a 2x plus 4. And then we're going to see what output we get. Again, in my independent variable for x, I can choose any number that I want, but my output is going to be dependent. Whoops, this should have been dependent variable. Sorry, this should be output. Your output is going to be dependent on whatever number I plug into this area right here. Let's start off easy and just plug in 2. Now, your order of operations still apply. Every time you have multiple operations, you must apply the order of operations that we have learned, PEMDAS. So we are going to do 2 times 2 plus 4. So I'm going to multiply first to get 4 plus 4 to get the output of 8. Again, I just took this 2 and replaced it for the x value. Let's do another input. How about 5? Now it would be 2 times 5 plus 4. 2 times 5 is 10 plus 4, because thou shalt not add or subtract until all multiplication or division is completed. You better hear that in your brain for the rest of your lives when you have an order of operations problem. So this output would be 14. Let's plug in, again, it's independent. I can choose any number I want. Let's get real crazy and plug in 100. If I have 100 times 2 plus 4, that's going to be 200 plus 4 is 204. My helper Owen is watching this video and he is impressed that I knew 100 times 2 quickly. So you can see these input tables are really simple. Simply plug in your x value into the rules that they give you to get your numbers out. Next, we're going to look at what we do if they give us the output and we have to discover the input. Next, we are going to listen to Mr. Hardesty, a teacher from Glencoe, who's going to teach us how to find the input if we know the function rule and the output. He's going to show us a method called the work backward method. Put this chart in your math notes and fill in the values that he gives you and do the things along with him as if it were me up at the board.
This is Mr. Hardesty. Let's use the work backward strategy to solve the next problem. Find the input for the function table. Our function, 4x plus 1, we have an input column and an output column. Typically, we know the input and we want to solve for the output. In this example, we know the output. Let's work backwards to see what the input would be. 4x plus 1 is our function. If we take our output values and work backwards, we'll find the input. That is, subtract 1 from 9, a difference of 8, and then divide by 4. And that quotient is 2. We'll do the same for 13. Subtract 1, which is 12, and divide by 4, which is 3. And for 17, minus 1 is 16, divide by 4, a quotient of 4. So 2, 3, and 4. Let's place those in the input column, and now we'll work forwards and make sure we're in good shape. 4 multiplied by 2 plus 1. 8 plus 1 is 9. 4 times 3, that's 12, plus 1, 13. And 4 times 4, 16, plus 1 is 17. So we've solved for the input by working backwards, 2, 3, and 4.
Now I'm going to show you a slightly different method to do this using what we learned about equations. So please draw this table in your notes right now. We're going to work to find the values for the input if the outputs are 6, 15, and 21. How I would think about this is as if it were an equation. So our first step would be like 3x equals 6. Now this looks just like the equations when I had to solve for x. I can do the inverse operation method, find my variable, it's being multiplied by 3. To undo a multiplied by 3, I divide by 3. Whatever I do to one side, I do to the other side. They cancel out. I'm left with x is equal to 6 divided by 3, which is 2. So now I can put 2 in here. 3 times 2 is indeed 6. On your paper, go ahead and try to find the inputs for 15 and 21. You can either use Mr. Hardesty's backward method or setting it up like an equation like I have done. Push pause until you have your input values found. Okay, I would have done this 3x equals 15 for our second output. Draw my line, find my variable, being multiplied by 3. How do I undo multiplication? The inverse, division. Whatever I do to one side, I must do to the other side. Cancel out. I'm left with just x. 15 divided by 3 is 5. So hopefully you found that 5 is your input value. And when you check your work, 3 times 5 is indeed 15. Next, simply apply 3x is equal to 21. Break it up, find my x. Need to divide by 3. Divide by 3. X is equal to 7. 3 times 7 is equal to 21. For those of you that did multi-step equations, you could have used the multi-step equations that Mr. Hardesty showed as well. For those of you that didn't get multiple step equations, just try this method for now. You should now be ready to complete homework 1, finding inputs and outputs using function tables.